Today we're going to start the last part of Chapter 2. This is, if we had our textbook, which you will soon, this is Chapter 2.7. It's the last section of Chapter 2, and it's on rational functions. A rational function is just a fraction, pretty much. But the parent function we haven't learned yet. The parent function for rational function is f of x is equal to 1 over x. And if you were to graph that, you graphed this last year in Algebra 2. You could take a look at it on the graphing calculator. But this basic function is called a hyperbola. It has two identical branches, one in quadrant 3 and one in quadrant 1. And you can do shifts and stretches if you wanted to take your graphing calculator out. If you wanted to add a +2, the whole thing would move up 2. Or if you wanted to put a +2 beside the x, the whole thing would move to the left 2. Or if you wanted to stretch it or shrink it vertically or horizontally, you could. Or if you wanted to negate it, you could reflect it across the x or the y-axis. But that's the basic parent function. And we have to talk about domains when we talk about rational functions, because a rational function really is something with a variable in the denominator. The domain is not all real numbers. And I abbreviate all real numbers with my fancy R. If you wanted to find the domain, you set the denominator equal to 0 and solve for x. And those values are not included in the domain. Set denominator equal to 0, solve for x. And those values are not in the domain. What rational functions have that polynomials don't have are they have asymptotes. And you learned about asymptotes last year. Okay, a rational function has a vertical asymptote, and oftentimes it has a horizontal asymptote. And we're going to talk about what the definition of asymptotes are. Okay, the line x equals a is a vertical asymptote. Of f if the function f of x goes to infinity or negative infinity as x approaches or x gets close to the value of a. From the right, or left. And what does all this mean? If you look back at this parent function, this parent function has a vertical asymptote at x equals 0. And if this function gets closer and closer and closer to x equals 0, the line x equals 0 from the left-hand side, then this function is going down, down, down forever. It goes down to negative infinity. So as x gets closer and closer and closer to 0, the function gets closer and closer and closer to negative infinity from the left. As you approach x equals 0 from the right-hand side, from over here, if you get closer and closer and closer and closer to the x equals 0, then this function goes up to positive infinity. And if you shifted this graph to the right or to the left, the vertical asymptote would shift with it. And the closer and closer you get to that line, x equals whatever that number is, then this function goes to positive or negative infinity. So that's a vertical asymptote definition. In this case, there's also a horizontal asymptote. So that's your first asymptote. Your second asymptote, the line y equals b, instead of x equals, it's y equals because it's a horizontal line. The line y equals b is a horizontal asymptote if the function f of x gets closer and closer and closer to that value b as x goes to infinity, which means it goes to the right forever, or x goes to negative infinity, which means it goes to the left forever. So we'll take a look at the horizontal asymptote up at our parent function. The line y equals 0 is a horizontal asymptote for this function because as x goes to infinity, which means it goes forever to the right, this function gets closer and closer and closer to y equals 0. It approaches 0. When this function goes to the left forever, when x goes to negative infinity, this function approaches y equals 0. It gets closer and closer and closer to y equals 0. So either from the top or from the bottom, this function gets closer and closer to the value of b. In this case, b is equal to 0. So those are the two of the type of asymptotes we're going to study this year, and we're also going to be looking at a third type in a day or two. Okay, so if you have, for example, if you have a function 2x plus 1 over x plus 1, and we're asked to find the vertical and horizontal asymptote, let's look at this graphically. Two x plus 1 over x plus 1. And you should probably do this along with me on your graphing calculator. If you take a look at this graph, you can see that as x gets closer and closer and closer to negative 1, the function goes to infinity from the left, goes to negative infinity from the right. So the vertical line x equals negative 1 would be the vertical asymptote. And as x goes to infinity and negative infinity, this function gets closer and closer and closer and closer to y equals 2. So graphically we can see that, and if you wanted to zoom in you might be able to see this a little bit better, but graphically we see that x equals negative 1 is the, and I just call it a VA for vertical asymptote, and y equals 2 is the, and I call it an HA for horizontal asymptote. And how we find vertical and horizontal asymptotes is, first of all, we're going to set the denominator equal to 0 and solve for x, and that'll give us our equation for a vertical asymptote. It's just like finding the domain of the function. Set the denominator equal to 0. So in this example, if we set x plus 1 equal to 0 and solve for x, we get x equals negative 1, and that is our VA. That's the easy way to find a vertical asymptote. The next thing we're going to do is find an equation of a horizontal asymptote. So to find the equation of the horizontal asymptote, if there is one, sometimes there's not, there are three cases that you have to consider. The first case is this: if the degree of the numerator is less than the degree of the denominator, so I'll say n is less than d, and let's off to the side say n is the degree of the numerator and d is the degree of the denominator. So if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is the x-axis. Or in other words, the equation of it would be y equals 0. The second case is if the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is the leading coefficients divided by each other. So the leading coefficient of the numerator divided by the leading coefficient of the denominator, and that's y equals. And I'll show you a couple of examples of that, of each one of these cases. And then the third case is if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. So we'll go through a few examples of each of these cases. If I have 1 over x minus 1, and I'm asked to find the vertical and the horizontal asymptote. Well, the vertical asymptote is, you just said x minus 1 equal to 0, solve for x. The vertical asymptote is x equals 1. The horizontal asymptote, because the degree of the numerator is 0 and the degree of the denominator is 1, then the numerator is less than the denominator, so the x-axis, or the line y equals 0, is the horizontal asymptote. The second example, 3x squared over x squared minus 1. This one actually has two vertical asymptotes because two values of x make the denominator go to 0. So we have x is equal to 1, x is equal to negative 1. There are two of them. Horizontal asymptote, the degree of the numerator and denominator are equal. So you divide the leading coefficients. 3 divided by 1 is 3. So y equals 3 is the horizontal asymptote on that one. Next example, 1 minus x over x. Well, this is written out of order. This should say negative x plus 1 if it was in standard form. But the vertical asymptote is x equals 0. The horizontal asymptote, the degree of the numerator and denominator are each 1, so they're equal. The leading coefficient is negative 1 over 1, so y equals negative 1 is that horizontal asymptote. And then the last example, let's say we have 4 over x minus 2 parentheses to the third power. And this should all say f of x equals on all four of these examples. The vertical asymptote is x equals 2. The horizontal asymptote, the degree of the numerator is 0. The degree of the denominator is 3. So since the numerator is less than the denominator, then it is y equals 0. And then the last example, if we have f of x is equal to 3x to the fourth over x cubed minus 2x minus 6. That's not very factorable. Let's say minus 8. And we'll have x squared minus 2x minus 8. There should be two vertical asymptotes. If we factor this, it would factor into x minus 2 times, x plus 2 times x minus 4. So the two vertical asymptotes are x equals 4, x equals negative 2. And there is no horizontal asymptote because the degree of the numerator is greater than the degree of the denominator. And that's it for today.